So the P&L was really a chance for you to get comfy using your calculator. So I really wanted you to pull out your calculator, make sure you know how to use the fraction key, get comfy using the fraction key to simplify fractions, do operations with fractions. So if you have any questions about your calculator, just shoot me a Zoom through Remind, and I can look at your calculator, because I have all three kinds that we have in class, and I can show you how to play with the fraction key on your calculator. So pull out page 308 of your P&L that you guys hopefully all did already. And I want to look at some of the conversion factors and kind of get used to what a conversion factor is. So I wrote down a couple at the top here, you can see in pink. And so I want to look at, well, what does 6 over 6 equal? Well, if you have the same number on the top as you do on the bottom of a fraction, that's always equal to 1. So 16 over 16 equals 1. 1 foot over 1 foot equals 1. Now, this is what the section is about. So instead of 1 foot over 1 foot, we're going to write in disguise 1 foot. For example, I'm sure everyone knows that there's 12 inches in 1 foot. So it doesn't look like we have the same thing on the top as we do on the bottom, but we actually do, because 12 inches is 1 foot, so this is equal to 1. And this is an example of what is called a conversion factor, and we use this when we do dimensional analysis. So you were asked in the P&L to find some on the next page, but here are some typical ones. 16 ounces in a pound, you might know that one if you do a lot of cooking. This one we'll use a lot, so you'll eventually get comfy with it, but in 1 mile there's 5,280 feet. And this one I'm sure you're aware of, that there's 60 minutes in 1 hour. But you can also write these the other way, right? You could also say 1 hour in 60 minutes. Okay, so this is some examples of some conversion factors that we're going to start getting comfy with. Now on the next page, on page 309, they worked through a problem, and I want to just do it on some scrap paper so you can see where they were thinking, working through 35 miles per hour. And their goal, their end goal, was to change 35 miles per hour. Their goal was to change that, looking down here, how many miles are you traveling in a minute? Okay, how many miles are you traveling in a minute? I guess we'll just look through this. So do you see they started off with 35 miles in 1 hour, and they wanted to know how many miles you're traveling in a minute. So the only thing we're allowed to multiply something by is 1, right? 5 times 1 is 5. 6 times 1 is 6. So we could only multiply this by 1 without changing the number, without changing like the value. So if I want to change this to miles per minute, I know in 1 hour there are 60 minutes, right? So do you see that if I have the same number on the top as I do on the bottom, right, or the same units on the top, those cancel because that's equal to 1, and now we can figure out how many miles you're going to be traveling in a minute. So I'm just going to pull out my calculator. So that's not a unit fraction yet, but if I have 35 miles in 60 minutes, if I put 35 over 60 in my calculator, and then if you use the fraction key, I want to show you this change key. Do you see this double triangle at the bottom? That's what I call change. And if I hit that, do you see it changes it to the decimal? So that's where they got the 0.58 miles on the top and 1 minute on the bottom. So the units are still the same, but the numbers now I put it as a unit ratio or a unit fraction. Okay, so you can see that's what they were doing down here. right? So it's 35 miles in 60 minutes, and then they pop that in their calculator. All right, so on the back, I just wanted to review some unit fractions that you guys might be comfy with. Just wanted to go over some unit fractions. So 1 day, I'm hoping you'll know, is 24 hours, right? That's a good unit fraction. In 1 week, we're going to use, there's 7 days in 1 week. And then sometimes they talk about a work week. So we'll see, instead of 7 days, when they talk about a work week, they talk about 5 days. So it just depends on what the problem says. $1, we're going to look at this unit, conversion factor. Now remember, they're reversible too, right? We can flip them. So we could say 100 cents in $1, right? So we can flop them, switch them around. 12 inches, we already did that. That's 1 foot. Or you could say 1 foot is 12 inches, right? And then for 1 mile, that's 5,280 feet. We're going to be using that quite a bit. So you'll get that one down pretty quickly. And of course, there's other ones. There's time. Maybe if I said 1 minute, you guys would say 60 seconds. Or you could flop that around, right? Or 60, or I should say flop. You could reciprocate it, is 1 minute. When you flip the numerator and denominator, that's called reciprocating it. So you could switch it or reciprocate it. So we're going to be using all of these in this section to do what's called dimensional analysis. So take a minute. I wish we were together. I'd have someone read the first paragraph, but maybe pause the video and you take the time to read the dimensional analysis of this problem situation and what it's used for, like cooking, finances, currency exchange. We're going to be doing a lot of these types of examples. So go ahead, just read the first 2 paragraphs and then we'll get going. All right, so let's look at the first one. It says, according to Toyota's webpage, a 2014 Prius can get 51 miles per gallon. Okay, you remember per means divide. So we've got 51 miles per 1 gallon of gas. And so that's on, oh, in the city. And then on the highway, it gets 48 miles per gallon. Okay. So it says, how many miles will you be able to drive in the city? So I wrote, this is in the city, if you have 4.5 gallons of gas. Well, if we get 51 miles for 1 gallon, and then we have 4.5 gallons, right? Do you see that if I write times 4.5 gallons, you see the gallons cancel? And then you just pull out your calculator. So 51 miles for every 1 gallon, well, just multiply that by 4.5. And that's going to give you the number of miles you're going to travel. So I got 229.5 miles. Okay? All right. So let's try part B. It says, how many gallons of gas would you need to drive 3,450 miles? Okay, so we know that on 1 gallon, I can go 51 miles, right? On 1 gallon, I can go 51 miles. So how many chunks of 51 can I get out of there? And that's going to tell you the number of gallons that you'll need. So if we figure out how many chunks of 51, because for every 51 miles I'm going to need a gallon of gas, did you guys get about 67.6-ish about 67.6-ish. And they didn't tell you if you were going to be on the highway or in the city. I'm just assuming that we were in the city. So that would be 67.6-ish. Probably we really should say 67.7, but that's how many gallons we're going to need, roughly. Okay? So that's just, thinking. That just kind of, we had to think about that. All right, you guys ready? So let's flip. Now I wrote on the top, remember, per means divide, and whatever follows the per, that goes on the bottom of your fraction. So I'm going to do this on a separate sheet of paper because there's a lot of steps to this, but I think it's easier if you see it just worked out rather than try to kind of follow this whole thing. So it says your paycheck for 2 weeks came out to $1,200. You work 8 hours a day for 5 days a week. So they want to know how much you're making per minute in cents. So per minute, the minute goes on the bottom and the cents goes on the top. So that's what our goal is. We're trying to convert our paycheck so that we will get it in cents per minute. All right, so I'm going to do this on scrap paper. You can follow their work, but I'm going to work it out so that we can kind of understand what's happening. So the first thing I always do is write out what we're given, okay? So we are given, get this straight here so you guys can see it, we're given that we make $1,200 in 2 weeks. All right, I can, right away, I know how to convert dollars to pennies, right? Because I know in $1 we have 100 cents. Does that make sense? Right? So I can cross off dollars, and now I'm halfway there. Now I've got cents on the top, and remember, we're trying to get cents over minute. So now I've got to convert that weeks to minutes. Now they said we work 5 days a week. All right? So I want to get rid of weeks and be left with days. Now weeks are on the bottom, so in order to cancel, I'm going to have to put weeks on the top. And I want then days on the bottom. We're eventually going to get that days to minutes, but we're going to stop here and take a pause and fill in the numbers. So they said in 1 week you work 5 days. Okay, so now let's make sure we can cancel our weeks. I have weeks on the bottom and weeks on the top. So now my units are in cents per day. All right, so I can go from days to hours, right? Because they said in 1 day I work 8 hours. So I want to get rid of days. So if days are on the bottom, I've got to put days on the top. And now we're going to have hours on the bottom. I've got to work my way to get to seconds. So let's see, let's cancel. So days cancel. Okay, so in 1 day, it said you work 8 hours. All right, well now I know how to go from hours, right, to minutes, right? So if I have hours on the bottom, I want to cancel it. So I'm going to put hours on the top and then minutes on the bottom. So let's see, hours on the bottom cancel with hours on the top. And in 1 hour, we've got 60 minutes. And that's our goal. So look, the only units we have left are over here. We have cents, right here, cents in the numerator, and minutes in the denominator. So now you just have to pull out your calculator. Now, there's a couple ways you could do it. If you just want to put in all of these fractions and just multiply. Go for it. You ready? So I have 1200 over 2 times 100 fraction over 1 times 1 fraction over 5 times 1 fraction over 8. Do you see what I'm doing? And then I pull out the fraction and then hit times, and then 1 fraction over 60. And then I pull out of the fraction. Do you see that? I'm using my arrow key. So it looks like you are making 25 cents per minute, right? So 25's in the upstairs along with the cents, and that's really 25 over 1. So the units on the 1 are minutes. That is a big old dimensional analysis problem. It's huge, right? But it's not hard as long as you read the question carefully, and then just know if you want to get rid of a unit, like here I wanted to get rid of weeks, so weeks is in the bottom, so I need to put weeks in the top so I can cancel it and then write the equivalency at the bottom. Right? I wanted to get rid of dollars. It's in the numerator, so I have to put dollars in the denominator and put the units that I'm looking for in the numerator. Right? It's all about these cancelings. It's not hard. It just kind of takes some practice, just some getting used to. So that's what they did on this whole page, right? That's what they did on this page. So we kind of just worked it out together. I think it's easier to talk it through than to try to look at what they were playing with. All right. So let's look at this page. They said, is earning 25 cents per minute, so 25 cents per 1 minute reasonable? Okay. So usually when we think of money, we think of how much we're making per hour. So this is where I want you to pause the video. This is where y'all would be working in your groups. Okay, so you know you guys can contact each other and talk about this. So this is now, I would say, get in your groups, and I want you to convert 25 cents per minute to what we usually think of. I want you to convert that to dollars per hour. Okay, instead of 25 cents per minute, I want you to convert it to dollars per hour. So pause the video. I know that this looks weird now, but it will get easier, I promise. It will get easier. So pause the video and then see how you do on these. Okay, so take a pause, work it through, and then come back and see how you did. All right. So we want dollars on the top and hours on the bottom. All right, so I know how to get rid of cents, right? So cents is in the numerator. So to get rid of cents, I want to put cents in the denominator, and I want dollars upstairs. So I'm hoping once you say, okay, now I've got to fill in the numbers, you'll know there's $1 and 100 cents or pennies. So look. We can cancel. There's cents in the numerator, cents in the denominator, so those cancel. So now I have $1. Now my units are $1 per minute, but I want dollars per hour. So minutes are in the denominator, so I need to put minutes in the numerator, so now I can cancel minutes, and I can go from minutes to hours. Right? So let's fill in the number. So in 60 minutes, we have 1 hour. So look, the minutes are going to cancel. So now I'm left with dollars on the top, hours on the bottom. So let's see, if you're making 25 cents per minute, how much you're making per hour. So I've got 3 fractions, and I just popped these fractions in my calculator. So there's 1 fraction times, and here, this is how I enter in the fraction quickly. I push the 1, and then I push the ND button, and then 100. And then I use my right arrow to get myself out of the fraction. Do you see that? And then times, and then 60, I hit my fraction key, and then I put 1. So how much are we making in dollars per hour? $15 per hour. That is definitely a reasonable salary. So yes, I would say the calculation is reasonable. Making $15 per hour is definitely a nice salary to be making, right? Okay. I wish we were in class together for this one, because I have a string that shows you how far you're going to be traveling if you are texting and look down for 4 seconds. I have a string, and then we go out in the hallway, or if it was nice, we go outside to show you just how far you would be traveling. So I'm definitely bumming we're not together. I can't use my string. All right, but let's go ahead and read the problem. So it says many states have banned texting while driving because it's dangerous. But I don't think, and it's very true, most people don't think if you look down at your phone for a few seconds, you don't realize just how far you travel. So let's just say you're driving 60 miles per hour. And, you know, on our highway, that's pretty slow, right? Most of us drive at least 65, if not faster. And you take your eyes off the road for just a few seconds. In fact, 4 seconds. They say, how many feet are you going to travel in that time? All right, so we are given, so this is step number 1. Always write down what you're given. 60 miles in 1 hour. Okay? And we want to know how many feet we're going to be traveling in 1 second. And then we can multiply it by 4 to figure out how many feet we're going to travel in 4 seconds. So I'm telling you now, your goal is to convert this to feet per second. That's what your goal is. And again, if we were in our groups, I'd say, okay, groups, everyone give it a try, and then we would report back in and we would compare our answers. So I ask you to pause the video and see if you can go from 60 miles per hour to feet per second. That's your goal. All right, so pause the video and see if you can get that to feet per second. All right, and then turn the video back on and I'll show you how to do it. Okay, give it a try. All right, you ready? So I know how to go from miles to feet because they said, remember, there are feet in 1 mile, and you don't have to memorize that. You don't have to memorize any of these conversions. I'll give all the I'll put like a little sentence there if so you don't have to memorize these. All right. Oh, I wish I could ask you guys this. So I want to get rid of miles and be left with feet on the top. So where would I put the miles so that I could cancel them? Right? If miles is upstairs, I'm going to need miles in the downstairs in the denominator of that fraction, and I'm going to put feet in the numerator. So do you see miles will cancel with miles, and now we have to fill in the numbers. So it said on the last sentence that there's 5,280 feet in 1 mile. Aha! So miles cancel, and now I have feet per hour. I don't want feet per hour, I want feet per second. So I know I can go from hours to minutes, and then minutes to seconds, right? So look at the denominator. So hours is downstairs. So if I want to cancel the hours, I have to put it upstairs, right? And then I'm going to put minutes in the bottom because I know how to go from hours to minutes. So let's fill in the numbers. So in 1 hour, there's 60 minutes, right? And look, I can cross off the hours now. Okay, so that works. Now I have feet per minute. I gotta get feet per second. So let's do one more fraction. So minutes are on the bottom. I want to get rid of minutes, right, and be left with seconds in the denominator of the fraction. So minutes have to go upstairs and seconds will go downstairs. So now look, do you see the minutes we can cancel? Let's fill in the numbers and then we'll cancel. So in 1 minute, there's 60 seconds. So look, minutes on the bottom, cancel with minutes on the top. And finally, I've got my units down. Do you see that? I have, the only thing I haven't canceled is feet on the numerator and seconds in the denominator. So let's see how many feet per 1 second you travel if you're going 60 miles per hour. So I've got 1, 2, 3, 4 fractions I'm going to put in my calculator. So 60 fraction 1 times 5280 fraction 1. And then I use my right arrow key to pull it out of the fraction. Times 1 fraction 60 times 1 fraction 60. So it looks like you're going to travel 88 feet in 1 second. And so the question said, how many feet will you travel in 4 seconds? So say you're on the highway and you look down and you text really fast, so your eyes are looking down for 4 seconds. So how many feet will you travel? If you go 88 feet in 1 second, well, let's multiply that by 4. Do you see the seconds go away? So 88 times 4. You'll travel 352 feet. That is really long. So it's about the distance of the hallway. So if you take the string and put it, if you're my morning class, my 8:15 class, and you take the string against the wall outside in the hallway, you're gonna go so far, you're gonna start entering into the other building, right? And it's 1 foot or 100 feet is gonna extend you into the other building. It's far. And if you're in my 2 o'clock class, 100 feet is probably the length of that hallway. And look, you're going over 3 of those. So you go so far. So that's why it's dangerous. Like, if something should run out in front of your car like a deer, right, and you're looking down, you're not going to see it. It goes so, you're going so far. If you look down for a few seconds, that deer, you won't see it coming in front of you, because that is a really far distance to travel in just a few seconds. All right, last little bit. You notice I crossed off number 5 and 6. I don't like 5 and 6. So we're going to just do number 4, and then we're going to look at a little bit at the OCE. So in Module 2, we talked about population densities. All right. So let's write down what we're given. So they say Tokyo is very dense. There's 6,038 people per 1 square kilometer. Okay. A kilometer is smaller than a mile. Okay. A kilometer is like, it's not a half. It's a little bit bigger than a half mile. So let's see. Use dimensional analysis to calculate how many people would live in all of Japan, which is comprised of 378,000 square kilometers. So let's just say for every square kilometer you have 6,038 people. So here, let's set it up and do a little dimensional analysis on it. Alright, so we have this many people per 1 square kilometer, okay? And they're saying that, they're just like thinking about this. So if the entire country was this dense. So for every 1 square kilometer, this is how many people they had. They just wanted to say, what would the population of Japan look like? So we have 6,038 people per 1 square kilometer, and this is how many square kilometers we have. Does that make sense? So for every 1 square kilometer, this is the number of people, and this is how many square kilometers. So we're just going to multiply those two. I mean, if you want to put this over 1, you can, but you see the square kilometers cancel, and you're just left with people. So let's see how many people. A ton, because would live in Japan if it was that dense. There would be a lot of people. So let's look. 3, 7, 1, 2, 3. Holy schmackies, it's big. Oh my goodness, let's write that down. I don't even know what that number is without commas. So 22, 8, 2, 3, 6, 4, 0, 0, 0. That comma is 1,000, that comma is million, and that comma is billion. Wow. So you would have over 2 billion people living in Japan if it was as dense as it is the density for Tokyo, but Tokyo is super crowded. All right, so the OCE is actually not bad. It's not bad at all. I don't want you to do number 2, but I really liked number 2, so I thought we would just talk a little bit about some of the ratios. Now remember, a ratio is a fraction. It's just another word for fraction. So I thought, well, let's just talk about a couple of them again because it's worth going over. So population density, we just did that with Tokyo. That's a ratio. It's a fraction. So you have total people over total square miles. And so when they talk about a unit ratio, that means you pop it into your calculator and put it over 1. So a unit ratio for population density would be people per 1 square mile or 1 square kilometer. Unit price, to find the unit price, you took the total price over the total amount, like if it was $2.49 for a 12-ounce box of Cheerios. And then the unit price would be if you pop it in your calculator and you get it for 1 ounce or whatever, 1 pound of whatever you're purchasing. So dollars on the top and amount on the bottom. That's the unit price. We talked about water footprint. Do you remember that? And it was the total water used per capita, but we know that per capita means per person. And boy, there's a ton more. There is a ton more. We talked about how many times larger something is than another. That was a fraction that we talked about the number of congressmen or of senators per 1 per in a state. So we used a lot. We've done a lot with this. So this OCE is pretty short. You don't have to do 2. I just thought we would do it. 1 is super easy. And then there's only 3, 4, 5, 6, and 7 left. So there's only 5 questions left. And that's hard is question number 7. So if you need help, you work with your partners. You have a lot of people that you have phone numbers for. But if you need help, send a remind that you want to do a Zoom room on your phone. Okay, and then I'll say, okay, give me a minute, and then on Blackboard is the link to a Zoom room. So I'll say, give me a minute, and less than a minute, you and I will be facing each other, and then we can talk face to face, how to walk you through these 2 problems. They're a little tricky, but give them a try, right? Give them a try first. And then the only other thing you have is the P&L. This is probably the easiest P&L we will have this year. It's 2 questions and they're super easy, and that will be due Tuesday at midnight. So if you notice that it's already open and it's due Tuesday at midnight. Now these OCE questions aren't due until the last Sunday of Easter break or spring break. Okay, so you have quite a bit of time to do them. Don't put them off. You'll have 3, 3.1, 3.2, 3.3. will be due, but you're going to have more than a week to do them. So I would try really hard to stay ahead, because when we come back after spring break, we'll have to finish this module up and then figure out how to get some tests in, okay? So let me know if you have any questions, and we'll talk to you again on Wednesday with a video on lesson 3.2. All right, take care, everyone.